So in this one we are going to explore the concept vectorization. In the previous one we explained how it is really important to have something that will uh, get us rid from using a lot of for loops. So we are going to dive uh, little bit into what vectorization is and how that works. So let's get the concept clear for first of all. So imagine you have big box of crayons. Inside box there are lots of tiny little colored pieces. Now let's say you want to color all these tiny pieces with different colors. One way to do it would be take each piece one by one and color it with a single color. But you cannot you imagine coloring them all with just one color and just moving that same color around every single piece? That sounds way easier, right? So that's a kind of like what happens in deep learning when we talk about vectorization. Instead of working on individual pieces like tiny little colored dots, we work with lots of tiny things called vectors. So think of the vectors like super small colored boxes where each box has a special color number inside it. We can store many of these boxes in a big array. So now let's say you want to change the color of these boxes at once, not one by one, but you can just take the single color and use it for every single box. This is called vectorization because we're working with whole groups of vectors instead of individual ones. So in deep learning, vectorization helps computers to do a lot of math calculation super fast. Imagine you have a really big data set like a huge list of tiny colored boxes and you want to change some colors numbers in each box. Instead of doing the math one by one for every single box, which would be taking you forever, we can use vectorization to change all the colors at once. So with just one calculation. Isn't it awesome? It's just like having a magical pencil that is changing all the colors of every box with just a single stroke. So computer uses special algorithm called neural networks and the special algorithms and new neural networks, not it is the name is not neural networks, like super smart brains to figure out how to do this math quickly and accurately so we can train machines to learn from our data. So vectorization is a really powerful tool that helps our computers work way faster and more efficiently when dealing with big and really big data sets, because that's what we're going to be dealing with, and we should be knowing the ways that will be making our whole life easier in terms of computation, because yeah, computation and time, that's what we're short on. So uh, and energy as well. So it's the reason why deep learning models can be super fast and accurate, recognizing the patterns in the world. So I'm hoping that is making sense. Now we're going to look into the mathematical behavior of all these equations. So we are really familiar with this equation now. I I hope, and the W will be looking like something like this. Like it can be a long vector having a lot of dimensions. X will be looking like a long vector as well. Like it can be long, it can be a short vector, uh, and uh, x will be from x will be belonging to real numbers where uh, from like an x, and W will be belonging to real numbers as well where nx will be the thing. So now let's see how non-vectorized thing will look like. So it will be something like we will be having for loop I'm just writing just for you guys to have the clear understanding of syntax. Don't take this as a code. We're going to explore and explain the code. So this is going to be uh, and z is going to be z equals to plus b. So this thing is going to be really uh, super slow. This thing tends to be slower than the vectorized ones. Now we are going to write the vectorized normal thing in Python. So what we are going to do is just np dot, we are going to write dot and w comma x, we are going to plus b, and that's what will be really like a super fast implementation of the same code. So we are going to look how fast this thing will work in compared to this in the Jupyter notebook I have opened in the tab. So let's head over to the code. So as you guys can see, we have imported in a numpy as np, and this is our array, and now we imported time. So we are having these dimensions, and we are having the uh, this thing in the for loop, and the this part of code is explaining us the vectorization thing. And when we run this thing, we can see the value of c is similar in the both cases, but the vectorized version is much faster than the non-vectorized version. So I was wrong, this one is vectorized version. So yeah, you guys can see np dot dot, and I hope the concept is clear, so you guys can implement the code. You can take screenshot and implement the code, but yeah, I'm just hoping the concept is clear. And normally when we think that we only needs like really high end GPUs to get done get these tasks done in our life, but that is not the case. You guys can run these things on your like CPUs as well at certain extent, and we can take benefit of the parallelism of the processors that have a lot of threads. And yeah, if we are having simpler programs like these, then we can run those on the normal CPUs as well, and they will be getting your thing done. And yeah, that's all about the vectorizations, guys, and we'll get more technical as videos will be getting progressed. So stay tuned and be legendary. See you guys in next video.